I'm Arka. I work at Notion, and sometimes at Notion we write blog posts about some of the stuff we do with Postgres. And one of the blog posts we wrote like last year was around how we kind of added a little bit more capacity to our Postgres tier by sharding and then resharding some of our databases to more physical instances. And a big part of that strategy was actually using PgBouncer to manage the failover from like the source database to target databases. And ever since that we published that blog post, I get a lot of just like comments from people whenever I talk to other people who care about Postgres and PgBouncer that one, that's a pretty common strategy, it turns out, that a lot of companies have used that kind of strategy to like swap out hosts. But also they just want a little bit more detail on like how specifically we did it. So I thought it'd be like a good kind of like meetup topic. Again, it's mostly just pretty relaxed. Like I don't really have that much like actual like content to share, but I'm happy to kind of like have a Q&A and just kind of talk through some of the strategies that other folks might have also used to do this kind of thing. And there are a couple of like just places where audience participation would be great. So if you want to, feel free to drop your answers in the chat in the few places where I have some questions. Great. With that said, I'll get started. So I have some very minimal slides prepared. Can everyone see my browser screen thing?
Yep.
Cool.
And
Okay.
just for like, I mean, I don't know if you need this like boost of confidence. I'm totally fine with loose slide meetup discussions. Like, I think I'm not looking for full 60-minute conference talks. Like, I think that's where some like good ideas and discussions come from. So, anyways, I appreciate you being here and I totally support your loose kind of, slides and some ideas, but not a full talk. So, anyways, thanks.
Yeah, thank you. Yeah, and so I'll just get started. Cool. So yeah, today we're going to talk about PgBouncer and a little bit about how we've used PgBouncer to do some failovers. Just to set some context of what I mean when I say failover, effectively what I mean is we use PgBouncer to be able to switch database instances without any downtime, or like very minimal downtime. So kind of switch traffic from one instance to another, or one instance to many other instances, depending on what you're trying to do. So yeah, my name is Arka. That's my email if you want to kind of reach out and chat about any of the stuff I talk about here. I work at Notion, obviously on the database team. Our team also does some other data store related things, but primarily I work a lot with Postgres, PgBouncer there.
Arka, how big is the database team at Notion?
Oh, it's tiny. We've actually like kept the company pretty lean, I feel like, as we have even grown. So the broader like infrastructure team is probably around 15-ish, 15, 20 people. But then out of that, we have a sub team called the data store team, which I'm a part of. And it's just four of us. And the data store team kind of owns all our Postgres, PgBouncer, Memcache, Redis, like really anything that can store some data. The reason we can get away with a pretty small team is just because we rely a lot on managed services. So, we're not actually running our own databases or our caches. We're relying a lot on like cloud providers to host that stuff for us. But there's still a lot of things we have to build on top of that to kind of make it scale for our use case. Yeah. Okay. So before we get started talking about PgBouncer, I want to quickly just talk about, how do we actually make a connection to a Postgres instance? And really, this is like a very simple kind of representation of what a direct connection to Postgres might look like. You might have many clients. A client is like a server or whatever trying to talk to a database. And then you have the client that opens a connection to the Postgres database, and then it can send queries and receive results. Um, there's obviously like there's a few things here, right? Like firstly, every direct connection to Postgres, it's not super cheap because you have to do some authentication. Like it's actually doing like a whole like TCP, like I think three-way handshake. There's like authentication happening. And then for every single connection that Postgres is getting, it's like forking a new process, which takes up memory and CPU on the Postgres instance itself. And so This can be good for, if you have very few kind of people connecting to your database, you probably don't need a connection pooler. Like if you only have a few hundred people that will ever connect to a database at the same time, Postgres can totally handle that in a really efficient and good way. And you can also just scale up the Postgres database instance if you need more like memory and CPU to handle more connections. But it doesn't really work well for thousands or tens of thousands of connections because then Postgres starts to really spend a lot of its time just creating connections and then like cleaning up the connections and then creating connections and cleaning up the connections, which just makes it, it's like a very memory and CPU intensive kind of process. So yeah, so database connections are expensive. Uh, Postgres needs resources to spawn a process for every connection that it gets, which is, not great if we're constrained on memory or CPU. Also, with direct connections, there's really no like safeguard from the client that is connecting to Postgres and what it can do. Because you're just directly connecting to a database, you can, hold on to a connection for a really long time if there's no timeouts or anything like that. Which means like bad clients could actually bring down the database pretty easily if you don't have some sort of like layer that is enforcing some timeouts and things like that. And then obviously, as your application or your service grows, the more clients you have connecting means more connections. So really, it's a direct one-to-one kind of relation where every request you get, if you have a service that is, that was getting 100 requests per second or something, that would maybe translate to 100 Postgres connections. If that service just suddenly, takes off and becomes popular overnight, and you have 10,000 requests per second trying to make connections to database, the Postgres might not be able to handle that without some sort of connection pooling or reusing those connections. And then, of course, there's a limit as well. I think the limit for max connections, like max connections is like just the number of maximum connections one Postgres instance can handle. I think it's something like, I don't know, like 26,000 or something. But the default is much, much lower. And I'm curious if anybody knows, if they can just drop it in the chat. What's the default for max connections in Postgres? Yes, yes, I see many hundreds in the chat. That's true. Yeah. So the default is 100, which kind of tells you that Postgres probably does not want you to make thousands and thousands of connections, or at least that's not like a recommended state, since the default is pretty low. Okay, so this is where connection poolers kind of come in. So we want to be able to make a lot of connections to our database, in the sense that we want to be able to serve a lot of client requests that we're getting, but we don't want to make a new connection for every single client request. So you can add some sort of connection pooler in front of your Postgres to handle that. In this case, we're going to talk about PgBouncer, but there's actually several Postgres connection poolers that are out there that I think are pretty popular. I think PgCat is another like newer one that I've seen a lot of folks kind of talk about and start to explore. There's probably many others that I don't know of. If you know of any good ones, feel free to drop it in the chat. I've always just like the company I work at has just always used PgBouncer, so that's been kind of my introduction to connection pooling for Postgres, but I'm sure there's many other ones. Regardless, whatever connection pooler you do use, what it does is it maintains the connection to the database for you, and it can handle on many, many client connections by reusing that connection that it maintains to the database. So here you see a PgBouncer instance is maintaining a persistent connection to the Postgres database, and then that PgBouncer instance is able to serve these three clients just by reusing that one connection. This is really great because this means that we can now scale up the number of clients that are connecting to our application, but not have to necessarily increase the number of backend connections we're making. There's a lot of like details here that I'm not really going to get into, but if you're interested, you can look into kind of how that persistent connection works. So for example, PgBouncer I know has different like pooling modes. We use a mode called transaction, which means PgBouncer basically will open a connection and keep it open for a single transaction. And then it'll release that connection back into the pool to be reused by another client. But there's other modes too. Like there's session, which means like PgBouncer will just keep the connection open for the whole session. And then there's like statement, which is like PgBouncer will open a new connection for every single statement and release it right away. So session is obviously like very friendly to the client, I would say, where it's like it's really holding the connection for a long time for you. And the statement is like a little bit aggressive. But transaction is kind of nice in the middle, where for every transaction, it will open a new connection. And then after the transaction is done, it will release it back, which we found works pretty well for us. So yeah, so hopefully that makes a little bit of sense. So just to recap, PgBouncer, just a lightweight connection pooler for Postgres. We use PgBouncer to scale a number of client connections. And like I mentioned, we run pool mode equals transaction, which means for every transaction, we would need a connection to connect to Postgres. And then after that, we'll release that connection back to the PgBouncer pool. And yeah, and really the aim here is we want to maintain like a consistent amount of database connections while being able to scale up the number of clients we can support. And just to go back and illustrate that here, um, in this diagram, you can imagine we could just support more client connections. Like let's say we got like, instead of 3, there were like 6. And let's say this one PgBouncer instance just cannot handle 6. We could just add more PgBouncer instances, right? Like this is like a layer you can kind of independently scale and kind of control the number of client connections you're able to handle while also making sure that you don't overwhelm the backend actual Postgres database. So that's kind of what we use it for. Another kind of, I guess, Q&A that I have for anyone tuning in. What do you think is a good number of connections? Like, what's a reasonable number of connections you might want to maintain per database in like a production deployment? And I'll kind of share what's worked well for us, but I'm curious what other folks kind of run just generally in your workloads. I doubt it's 100, right? It's probably a little bit too low for a lot of production kind of use cases. Okay, looks like there isn't 100 and less than 10,000. Yeah, yeah, somewhere between 100 and 10,000, I would say that's true, Andrew. Um, yeah, so I don't know. I don't think there's any like one right answer here. Really just depends on the kinds of queries you're doing, how fast your queries are, how often you can reuse connections. Like there's a bunch of factors here. But for us, we've found that generally running around 500 to 1,000 connections is okay. Like Postgres can really well handle anywhere between 500 to a couple thousand connections. But then we start getting into problems when it goes beyond that. So for us, we kind of try to maintain that 500-ish number as like a good point that we can kind of feel confident that it's okay in terms of memory and CPU and all these things.
That's
Great.
what I've
Yep.
mostly heard too. Like just in terms of like I hear a lot of people using hundreds. I've rarely heard of people running like thousands of connections in a single Postgres instance. Usually people are they're doing something else first, right?
Yeah, yeah. I mean, also it just depends on like the instance types you're running, like how much resources there are on the database itself. But yeah, for like, not just the ginormous instance, I think 500 is like a pretty reasonable number that we have found works well. So we do have a couple databases that are more in the 1,000 range, but those are giant, like 16x large type hosts. So there's a lot of memory and CPU there. Arka, do you configure max connections on Postgres to be 10,000 even if you're sending 500 through a PgBouncer instance? Yeah, that's a great question. For us, we configure max connections to be 5,000, but we never actually like if we ever get to 5,000 connections on any of our database, like there are other problems. It's like it is not going to work anyway. Like it's usually out of memory or out of CPU, or there's like some bad query that is just taking over all the resources. But yeah, 5,000 is like what we have configured max connections to, and we try to maintain around 500 uh, like actually in practice. Okay, great. So that's a little bit about PgBouncer. The one cool feature I want to talk about with PgBouncer, which relates to the failover thing, is PgBouncer has this admin console. So we can like click into it and kind of just like take a look. So if you look at the PgBouncer docs, you'll see that there's this admin console. Um, this admin console is essentially like a way for you to connect to the PgBouncer process, and it gives you some APIs to like control the process and also just get a little bit of information about your PgBouncer um, and your databases. So you can access the admin console pretty easily using pSQL or really any other tool that you connect to any Postgres instance with. And you'd connect on port 6432 because that's the port that PgBouncer runs on. Note, you would connect on port 6432 to connect to PgBouncer, but PgBouncer is going to connect on port 5432 to your like actual downstream databases. And this admin console has a bunch of cool stuff. Like it provides you some simple like show queries. So you can run things like show stats. You can run things like show servers, which kind of gives you like all the servers that PgBouncer knows about. You can run things like show clients, which shows you every single client connection that that PgBouncer instance is handling and what the state of it is, like if it's active or waiting. So really, it's really useful for debugging. Um, but the thing that's really useful for failovers, which we've used, is this, let me scroll down a little bit, are these process controlling commands. So PgBouncer has a bunch of commands that let you control the PgBouncer process itself. And what I mean by that is you can kind of tell the PgBouncer process whether you want to, pause traffic for a database, whether you want to disable traffic for a database, whether you want to reconnect all the clients that are connected to a database. Um, and so it provides a few of these APIs like pause, disable, enable, reconnect, kill, suspend, resume. Um, and this is really the crux of how we're able to kind of use PgBouncer to be able to stop the world in some sense. For running, if we're running our databases and PgBouncer is sitting in front of it, we can kind of stop all the traffic going to it, and then swap out configurations or whatever we need, and then resume the traffic going to that database. So I just wanted to kind of quickly walk through this. I definitely encourage checking out these docs if you're interested in more details. I find them really kind of simple and easy to just like Command F through. It's really nice. Yeah, so let's go back to the slides. So there's a bunch of these process control and visibility commands, but the three that we use for failovers are pause, resume, and reload. And I'll get into how that works in the next slides. But this is really useful, actually, for a lot of things. It's useful for things like major version upgrades. It's really useful for any time that you don't want to do an in-place operation that will take downtime. And so in that sense, if you can set up another database with your preferred configuration, so for example, if you're doing a major version upgrade, if you can set up that new database on the new major version and replicate your changes, you can use PgBouncer to switch traffic from the old database to the new database, which usually is much safer and much faster than trying to do an in-place major version upgrade. Similarly, you can use this if you want to test a really complicated index statement. You don't know how long it might take to create. You're kind of scared it might lock up the database. Again, you can set up another database, run the index creation there, and if that succeeds, just switch traffic to that one instead. And there's really like two key ingredients here. One is running Postgres, and two is leveraging logical replication to keep multiple databases in sync. But once you can do that, you can kind of swap traffic between them using PgBouncer. Um, so concretely, this is kind of what we're doing in PgBouncer when I say we want to swap traffic from one host to another. Essentially, PgBouncer has like a config that you render on the PgBouncer instance itself, which tells it about the database. It tells it like what DB to connect to for that database key. It tells it the host. It tells it the port to connect on, and you can configure a few other things. But basically, this is how PgBouncer knows like, oh, when I get a query for demo database, I know that that means that I should connect to dbhost.com and I should connect to the demo database in that DB to be able to serve this request. And so what we want to do is we want a way to be able to swap out this DB host from whatever this old value is to the new value as fast as possible so that our users experience no downtime, but behind the scenes, we've actually completely swapped out the database that is serving the requests. So like I mentioned, the first step to doing this is just simply setting up logical replication between your source and your target. So you can see here, we have a bunch of clients, PgBouncer, and we have a Postgres database, that's our source. And we have a target database that is like replicating all the changes from the Postgres database. So these two are in sync, but all the traffic is still going to the source, right? Uh, then the next step is we issue a pause command on our PgBouncer instances for that database. So whatever this database is called in PgBouncer, let's say it's called the Meetup demo, like in the last example, I would say pause Meetup demo, which means that now any new queries and connections that try to connect to that Meetup demo database, PgBouncer will not allow anymore. PgBouncer will kind of buffer the connections on its end because it's going to try to, because it's paused, it cannot make any new connections. So it'll buffer the new connections that come in, and it'll, oh, someone's saying, do you mean to be sharing slides right now? Currently not shared for me. But can you
I
all see
see
the,
your slides.
huh,
Oh, Andrew, maybe you clicked on the wrong thing. I did that recently when I was Arka, I can see your slides.
okay.
I recently I clicked on somebody's like face or something and like the slides went away. I think you probably just had like a little Zoom blip, maybe.
Okay. Carry on, Arca. Yeah, it's my issue.
Okay, trust me, they're great. I can share them later too if you're interested. But Andrew, can you see my screen when I do this? Like, can you see anything now?
I was watching your slides, but then I like went to, backgrounded Zoom and brought it in the foreground, and now I just see you. I don't,
I
so I
think,
think,
yeah, I think you have to you've clicked off of the screen and I did this to myself recently too.
Maybe I'll share again.
oh, now it's back. I don't
Okay.
know what changed though. I just like command tabbed a few times on Mac OS and now it's back. I don't know. Okay.
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 No,
Sorry for the distraction. Please
no,
carry
thanks
on.
for thanks for calling it out. I think it would make no sense if I have been describing pictures that you can't see. Anyway, cool. So yeah, let's continue. So then yeah, so let's say we want to swap from this source database to the target that we're replicating to. We can issue a pause command in PgBouncer using the admin controls we just looked at earlier, which will stop new connections from coming in for the source database, and it'll drain the existing connections. While this is happening, basically what we need to check is we need to check if the source and the target are actually in sync, right? Like that's how we know that it's safe to swap traffic from the source to the target because they have the exact same data. So after we issue a pause, what we do is we basically just run this query that just measures the distance between what the source has flushed and what the replica has said that it has flushed, the LSN number. The LSN is like basically an identifier of like every single write that happens in Postgres. It's what goes into the wall log that you might know about. So we just run the simple query that says, give me the current wall LSN of like the primary server and compare it with what the flushed value is that the replica has told me about, and save that value as the distance. And we basically keep running this query until the distance is 0, which means that, okay, all the queries have stopped and the source and the target are totally in sync. At this point, it's safe to now swap traffic from the source to the target. So what we can do is we can break off any connections. And before we swap traffic from this database to this one, we actually do one extra thing so we can roll back if we need to, which is we reverse the replication stream. So if you remember before, we were replicating changes from this database to this one. But at this step, we actually now cut off that replication and we set up a replication stream from the target back to the source. This is simply just because once we switch over to the target, if something goes wrong, we can just apply this exact same mechanism to go back, because all the changes from the new database will also go get synced with the old one. So they'll still stay in sync, even though the traffic has been switched over. Once we reverse our application stream, the last step is just to resume traffic. And once you resume traffic, now the traffic will go to the new database, and the replication will go to the old one. And after some point, when you're confident that the new database is performing as you expect, you can just break off that replication stream and deprovision that old database. So this is like a very high level kind of overview of what our failover mechanism looks like in the past. But you might be wondering, like, why do you actually need this? Like you said that you run on, cloud providers, PgBouncer reconfigured in there, host one. Yeah, essentially, between step, step three, actually before step three, like in step one, before we issue the pause, we render this new config on the PgBouncer instance, but we don't reload it yet, so that once we are confident that the replication is caught up, before we resume, we actually reload the process to pick up the new host for the same database key, such that when we resume, the new traffic will go to the new host. I have the next slide explains this a little bit more, but yes, there's a lot more steps in here that I haven't included in the diagram just because I didn't want to I was just lazy. I could probably make this like a 10-step diagram, honestly. Um, but thanks for the question. Hopefully that makes sense, Chris. Um, yeah, so as I was saying, you might be wondering, like, why do we have to build this like intricate kind of failover thing? Most cloud providers, like Amazon, for example, if you're using RDS, provides you like a way to just use a multi-AZ configuration where you can just fail over from like, one instance to another, and you can do like version upgrades that way. Really, this just goes back to what I was talking about earlier, where we want to do this because we want full control over our Postgres databases. And we don't really want to be reliant on running anything like a version upgrade in place. Because once you kick that off, your database is unavailable and you don't know how long it will take. Sometimes it might be a couple minutes, but sometimes it could be many minutes or hours. And for us, that's like not a reasonable kind of risk to take, which is why we prefer a setup like this where we completely know that the two databases are fine and like they work as we expect, and we just want to swap traffic between them instead of going through waiting for operations to complete. Yeah. So, related to the question in the chat, here's like a little bit more detail actually about what the process looks like. I'll kind of walk through it, but feel free to just save this slide if you're curious. So again, the first thing we do is we actually update the host in the PgBouncer config to the new database that we want to fail over to. But we don't reload the process yet. So PgBouncer is not connecting to that new host, but on the PgBouncer instance, the config file is changed. So the next time we reload, it will pick up that new host. Once we have updated the configs to what we want, we pause traffic to the database that we're failing over to in PgBouncer. And at this point is actually when the database is unavailable, because once you pause traffic, PgBouncer is not going to let any more connections happen. So this part is very critical to be as fast as possible, because this is essentially when you can have downtime. So while the database is in a pause state, we wait for the replication lag to get to 0. We also kill any active queries that are going on for longer than a few seconds, because we don't really want to wait too long in this process. It's better for us to kill ongoing queries and let them retry. And then we flip the replication stream. So the way we do that is we stop the subscription from the source to the target. We drop the replication slot on the source. We create the replication slot on the target, and then we subscribe from the target back to the source, just because the target is what's going to get the traffic once we unpause. We also remove login permissions for any users on the source DB just as a precaution, just in case any other services try to connect to it, it will not be able to anymore because the login permission is just removed from the source DB in general. And finally, once all these steps are done, we can issue a reload command to PgBouncer using the admin console, which will pick up the new config that we rendered. And once the new config is picked up, we can issue a resume, which just unpauses traffic. So yeah, like hopefully this makes sense, but this is basically like a written version of what we have in our code to do this, which is like just a simple script that we've written. And yeah, last thing I want to touch on is, what are the kind of components needed to be able to do something like this? To me, I think there's two real components. One is you need to store your PgBouncer configs somewhere dynamic, meaning you cannot have your PgBouncer config checked into your code because you can't wait for a code deploy while your traffic is paused, right? So you need to store it in like S3 or some kind of key value store such that you can update that key value store really fast, and then you can reload your PgBouncer instances to download that new config. And then the second thing I think that's really important is obviously you need some way to communicate with the PgBouncer process via the admin console. So if you're writing code, you might need like there's no API that PgBouncer provides to that admin console that I mentioned. So you might want to, SSH into the hosts and write something to do it that way. Or you can maybe even build your own API that kind of abstracts the SSH away from you and it maintains a admin connection. I don't know. We have found SSH is fine. Like we don't have that many PgBouncer instances running, so our script simply just SSHs into all our PgBouncer instances, connects to the admin port, and just issues the commands. There's a few questions in the chat. Okay, Elizabeth. Do you do any pre-warm stuff with the new primary, or is that done since it was replica? It's a good question. So I think there's two things. Like one, yes, since it is logically replicating all the writes, it already kind of gets a sense of the write traffic, which is good. But we also do this thing called dark reads, where we basically simulate application traffic both to the new database and the old database. And we throw away the results from the new database, but we just want to send queries to it so that the buffer cache and all these things can be comparable to what our production workload is, such that when we switch over traffic, it won't be like a huge problem.
At what point in the process does that happen? Like, go back to your little like
Ah,
10.
this is way before any of the stuff. This
That's
is like
okay. Yeah, that's before any of it. That's just
This is
part of
like when we
like
have just
thread. Okay.
provisioned the new host and replicated. We do a bunch of stuff just to make sure that the indexes are working correctly, that like the queries are performant or similarly performant to what we expect.
Okay, that makes sense.
Yeah. Um,
I was also going to ask you, do you use the PgBouncer foreign data wrapper that like lets you kind of get some stats from PgBouncer? I know we've messed around with that. Chris is here and he probably knows a bunch more about that than I do.
no, I'm not sure about that. I don't think we do. We use PgBouncer. We get stats from PgBouncer using, I think, a Datadog connector that we have.
Okay.
Um, At least that's what I think. I'm not sure. I'm not familiar with the foreign data wrapper thing, at least. Sorry, there was one more question in the chat. I imagine PgBouncer is hosted on an instance, i.e. EC2 or something. How do you prevent a single point of failure if the instance that's PgBouncer is sitting on goes down? Yeah, Jared, that's a really good question. And yeah, we deploy PgBouncer on EC2 instances exactly as you predicted. Um, for us, we really don't have anything that we have built to prevent a single point of failure because we have hundreds of these instances running. So it's okay if like one EC2 instance has a problem, because we run our EC2 instances on ECS, which is like Amazon's uh, like uh, like Kubernetes type thing, where basically it's like a containerization service. So we run health checks constantly on these containers. And as soon as health checks start failing for whatever reason, ECS will actually replace that task for us. So it takes it out of the rotation so the load balancer can no longer route queries to it. And then it just replaces it with a new task. During that time that the instance is struggling, or there's some problem, yeah, there's a few queries that would fail if there's queries that are still being routed to that faulty like task. But usually our health checks are pretty fast at detecting when some issue happens. And as soon as the health check fails, ECS replaces it. Okay. Last thing is I had a quick little demo. I don't know. It's not really anything crazy, but I feel like sometimes it's just fun to kind of see the kind of things we're talking about. So I wanted to quickly show like what these admin commands in practice actually look like. So what I did was I wrote a very simple script that essentially just, connects to my local Docker running Postgres, using PgBouncer. So the important thing here is the port is 6432. And I set a pretty short timeout so we can see what happens when PgBouncer is paused. But actually, in reality, you probably want your connection timeout to be a little bit longer because you don't want to fail queries right away, right? You actually want PgBouncer to be able to kind of buffer for at least like maybe 30, 40 seconds before it fails that connection. Because ideally, by that time, you can finish your failover and you don't have to like fail anything at all. Yeah, and then basically, I just have a simple thing that just like pushes 1,000 connections and then just tries to connect to all of them at the same time. And if it works, we'll get a little successfully connected log. It tells you when it connected. And if it doesn't work, we'll get an error. So, and then in the bottom right, I have like the PgBouncer. Maybe I can show this real quick. I have like the PgBouncer like demo. What do you call it? Admin console. So this is what I mean by it's like PgBouncer provides you, like an admin console where you can log in and just run things like show clients or show pools. These were kind of the things we were looking at in the docs, but this is just what I have running in this thing. And this is actually what I'll use to kind of pause traffic. And then on this right-hand side, I basically just I'm tailing the PgBouncer logs just so we can see new connections come in. And on the left-hand side is where I'll run the script. So first I'll just run it while the database is resumed. So what we should expect to happen is we should be able to make all 1,000 connections, even though the max number of backend connections we want is 100. So basically, we're saying we want to make 100 connections to our backend Postgres database, but we want to be able to service 1,000 client connections. So let's see if that works. So you can see here, we were very quickly able to make all 1,000 connections. And on this side, you see all the connections kind of coming in. I think that the interesting thing here is if you look at like the new connection, oh, is that how it works? Is that the log? Login attempt. Yeah, sorry. So you can see in the logs, we get 100 login attempts. This is just because we have restricted like PgBouncer, like our backend to 100 connections. But in our script, we're able to actually make 1,000 connections because it can reuse the same connection for some of these requests later on. Now we'll try pausing our database and we'll see what happens when we do that. So I'll just issue the pause Meetup demo command. And if I pause it, it should not be able to make any new connections. So when I run this after 5 seconds, it should just fail, I think. Yeah, you see, so what happened here was we sent those 100 connections, but actually, like none of them could connect to the database because we don't see any timestamp for when it connected. And basically, all of them after 5 seconds just got a timeout exceeded when trying to connect. And that's just because the database is still in a paused kind of state, right? If we resume it, so for example, let me try running this again, and then let me resume it just to kind of show that. So if I resume the Meetup demo now, you should see all these connections kind of work. As soon as I resumed it, you see like as we were able to actually get a response from the DB because that means the PgBouncer was like, okay, great, like now I can allow all these connections that are waiting to happen. So let me try to do those. Yeah, so that's kind of all I had. I don't know, just a silly little demo, but I feel like sometimes it just helps to see these components working in action. And I know a lot of the stuff I talked about here is maybe new to you, or maybe you know a lot about it. But I find with most things with databases, Postgres, PgBouncer, it's just fun to try out on your own. So, it's really easy to spin up Docker containers running PgBouncer, Postgres. PgBouncer especially has very simple authentication mechanism you can set up. Like you can just use an MD5 hash and like you can render like a few users and passwords and then easily connect through it that way. But I think that's like some of the best ways to kind of just learn how these tools work and try it out for yourself to see like what is the impact of using a connection pooler or what is the impact of if I pause a database or resume queries, things like that.